Okay, so as in the last video, we have derived the formula for finding the frequency of mass spring system or frequency of motion under elastic restoring force. Initially, we distinguished between time period and frequency. Since these both are very significant factors, we must distinguish between these two. If we would not be able to distinguish between these two, we would never be able to understand what frequency is and what is time period. That's why we initially distinguish these two terms, the frequency and the time period. Initially, we derived the formula for finding the time period by its general formula, which is t is equal to 2 pi over omega. What is time period? Actually, time required to complete one cycle. Time required to complete one cycle is what we call the time period. Time required to complete one cycle is called time period. Then we said what is frequency. Number of cycles complete in 1 second is what we call the frequency, right? So we also said that frequency is the reciprocal of the time period, right? So f is equal to 1 over t, and we were already known about the formula for finding the time period, right? So we just substituted the value of time period in the formula of frequency. F is equal to 1 over t. So f is equal to 1 over 2 pi into under root m upon k, right? So we further simplify it and we got our final formula, which is equal to f is equal to 1 over 2 pi under root k over m. And we discussed the SI unit of frequency as well, and that was hertz. In today's video, we are going to find the velocity of the mass spring system or velocity of the motion under elastic restoring force. So what we are going today is we are going to drive the formula, driving the formula for calculating velocity of mass spring system. Velocity of mass spring system. So we don't have very big derivation for it. We just need to use the formula which we initially derived for finding the velocity of the motion under elastic, not motion under elastic restoring force, however projection of a particle which is moving along uniform circular path, or the connection between uniform circular motion and simple harmonic motion, right? So we need to use that formula and we just need to substitute the value of omega in it, and we're going to have our final formula for finding the velocity of the mass spring system or velocity of motion under elastic restoring force. So let's use the formula of velocity. Formula of velocity of projection of a particle, projection of a particle which is moving along uniform circular path, along uniform circular path, right? So what was that formula? That formula was V is equal to omega under root x naught square minus x square, where x naught represents the amplitude, the maximum displacement from the mean position to the extreme position, since displacement is always taken away from the mean position, right? So now we are just going to substitute the value of omega here, right? Since we know that here we don't have anything to do with omega in this case, right? So what we are going to do today is we are going to substituting the value of omega. substituting the value of omega. And we know that the value of omega we have already found by comparing the two acceleration formulas, right? The acceleration of motion of a projection of particle along uniform circular path, and motion of particle under elastic restoring force, right? We compared those two formulas of acceleration and we found our omega, which is equal to under root k over m, right? Now we just need to substitute this under root k over m in the above formula, right? So what we're gonna have, our final formula is v is equal to under root k over m, under root k over m into under root x naught square minus x square. This is what we have, our final formula for finding the velocity of the mass spring system or velocity of a motion under elastic restoring force. See what we did, we initially wrote the formula of the velocity of a projection of particle along uniform circular path, which is v is equal to omega under root x naught square minus x square. Then we just needed to substitute the value of omega, and we did that, right? So we found our value of omega as well, and that was equal to under root k over m. We just substituted this under root k over m in this velocity formula, and we got a final formula for finding the velocity of the motion under elastic restoring force or Hooke's law or mass spring system, which is v is equal to under root k over m into under root x naught square minus x square, where x naught square is the maximum displacement, x is the just displacement, k is the spring's constant, m is the mass of the body. So this was all for today. In the next video we're going to have our maximum velocity and the minimum velocity.